Question 4. Last century, scientists used evidence from the alpha particle scattering experiment to develop a new model of the atom. In the experiment, alpha particles were directed towards a piece of gold foil. So you should know about this experiment, you should know about this evidence. What does an alpha particle consist of? Seriously, people who are getting this wrong, you are doing no revision whatsoever, and it's just disappointing. So we've got 2 protons and 2 neutrons. This is basic, 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 basic. We just did it. The gold atom has the symbol Au. How many neutrons are there in the gold atom? Well, just a reminder, this is the atomic number, and that tells you the number of protons. This is the mass number, and that tells you the number of protons and neutrons, because both particles weigh 1 atomic unit each. So if we know the number of protons, and we know the number of protons and neutrons, then we can just take one from the other. So 197, take away 97 is, I'm not going to take the chance of getting this wrong in an exam situation, because when you're in an exam situation, you tend to stress out a little bit. So you just want to make sure that that's right. So number of neutrons, 118, that makes sense. Now, the next bit of this, alpha particle scattering experiment led to the plum pudding model of the atom being replaced by the nuclear model. So we've got results predicted by the plum model and the actual results. So it literally says these are the results predicted by the plum pudding model. All particles undeflected, and the actual results, some particles slightly deflected, tiny proportion of particles deflected through large angles, but most go through undeflected. They want you to use these words. They literally want you to say, oh, they thought this was going to be the thing, but this happened. This is why. Okay, so they keep that in mind when you're writing this out. It's a 6-mark question. Describe how the actual results led to the plum pudding model of the atom being replaced by the nuclear model. You should include details of the plum pudding model and the nuclear model. They cannot make it easier, more directed on what you need to do. So you need to say what the plum pudding model is. So we'll talk about the plum pudding model to start off with. So the plum pudding model, and you write everything you know about it. Is a basic model of the atom. There are electrons in a sphere which is made of positive, it's like the cytoplasm in a cell. It's like the material. I'm just going to call it material. I'm sure there's a better word. Positive material. Overall, the charge on this atom is 0. It's neutral. So I'm going to even do a little diagram just to show. I've got little negative charges. Overall, it's positive. So this bit here, this ether, that's the positive bit. It's like the cake section, and these are like the plums. So these are electrons. There are no neutrons in this model because the neutrons were not discovered until way after this. So you should know that. People who start talking about neutrons, the person's going to try and ignore it, but they're going to think, oh, this person doesn't know their stuff. Then you can say, okay, so the problems, so originally the alpha particles are thought to go straight through I'm going to get rid of the word solid. Straight through the nucleus, or sorry, there is no nucleus, through the atom with no deflections. But that didn't happen, did it? Actual results by the alpha particle scattering experiments. That didn't happen. The actual results were that most alpha particles went straight through. Some were deflected. At small angles. This is where we can start saying why these things happened, and very few. I'm not sure if I'd say bounce back, because it has to hit to bounce. It doesn't actually hit. It gets repelled when it gets very close, but it doesn't actually hit. So deflect, we're going to use the words they've used, deflected through right angles. Larger angles. So we don't have to say even that means that's a positive nucleus. That means we can just say this led to, and by the way, you're never going to write what you need to write for 6 marks in this small space. So always expect to go on the nuclear model, not the Bohr model. There's no shells, there's no electron shells going on, there's no neutrons still. It's still just negative electrons, but they know that there is a positive nucleus now, which consists of a small, dense nucleus with positive charge. In the middle, and negative electrons orbiting the nucleus. Most of the atom is empty space. So just to finish this off, I might as well put in my little positive nucleus. Shorthand for positive, by the way. And we've got some electrons orbiting. Okay, neutral atom. Those who are talking about not a neutral atom, seriously. So this is one of the examples of a 6-mark question that you could learn beforehand. There are only so many questions like this that they'll ask. And you might as well just learn it, so you don't have to sit and think about it and second guess yourself.